determine whether the following function is odd, even, or neither. And here we have the function f of x is equal to 7x cubed plus 4x minus 2. So to get us started, let's quickly recall the definitions for even and odd functions. So we can recall that for any x value in a function's domain, we say that that function is even if f of x is equal to f of negative x. And similarly, we say that that function is odd if f of negative x is equal to minus f of x. So to get us started, we'll want to keep our strategy for determining whether a function is odd or even in mind, and begin by finding and simplifying f of negative x. So here, we want to go ahead and replace each one of the x's in our given function with negative x. So we can rewrite this as f of minus x is equal to 7 multiplied by negative x cubed plus 4 times negative x minus 2. Now keep in mind, we have a negative value raised to an odd power. So we know that this is going to result in a negative value. And we can rewrite this as minus 7x cubed. Now positive 4 times negative x leaves us with a minus 4x minus 2. So looking at this new function f of negative x, we want to compare this with the given function. Now we can see, unfortunately, these two values are not equivalent. F of negative x has the negative terms for the first two values, whereas our given function has positive terms for the first two values. So we can conclude here that since f of x does not equal f of negative x, the given function is not even. Now, this doesn't mean give up. This simply means that we need to proceed to step 2 and go ahead and find and simplify minus f of x. And again here, let's keep in mind our given function. We were given at the start f of x is equal to positive 7x cubed plus 4x minus 2. Now here, we want to find minus f of x. So for safety, let's incorporate parentheses around the entire function to remind us that we need to distribute this negative through to each term. So distributing the negative, we see that the signs of these change to minus 7x cubed minus 4x, and a negative times a negative value produces a positive 2. So remember, to determine if a function is odd, we are going to compare f of minus x to minus f of x. And here we can see our first two terms are the same, but unfortunately, we have a positive constant and a negative constant in the other, which allows us to conclude. So we can say that since f of negative x does not equal minus f of x, this is not an odd function. Now, since we have observed that f is not even and that f is not odd, this means that the function we are working with is neither odd nor even. So this example is an important reminder that no matter what a given function looks like, we should always check using our definitions to make sure what the accurate result will be.